Toyota has developed something completely different, but does this signal one of the most significant shifts in the automotive world? Let's dive in and find out. Before we explore
the
what
entire
Toyota's
EV
CEO
market.
has revealed,
Unlike current
let's take a
electric
moment to
vehicle
understand
engines,
their journey.
Toyota has developed something
Toyota
completely
has long
different.
been a leader in
But
the
does this
fast-paced
signal one of the
automotive
most
industry,
significant
and now
shifts
they're
in the
making one of their boldest claims yet, leaving the EV world buzzing with anticipation. Imagine an engine so groundbreaking that even the most devoted car enthusiasts are left speechless. This new engine is truly a game changer. Recently, Toyota announced the development of a hydrogen combustion engine. However, this isn't just any hydrogen engine, it's a complete departure from the all-electric trend that many manufacturers are following. Toyota has developed a brand new technology, one that we've never seen before. As the name suggests, this hydrogen combustion engine uses hydrogen as its primary fuel. Unlike conventional engines that release carbon dioxide, this engine emits only water from its exhaust, making it a revolutionary step in reducing the global carbon footprint. So how does this engine work? Instead of following the electric vehicle trend, Toyota has chosen hydrogen combustion to reduce emissions. Hydrogen, the most abundant element in the
fast-paced
universe,
automotive
has the
industry,
highest specific
and now they're
energy
making one of
density
their
any
boldest claims
non-nuclear
yet,
fuel.
leaving the EV world
When
buzzing
used
with
as fuel,
anticipation.
hydrogen is
Imagine an
exhaust-free
engine
and
so
non-toxic,
groundbreaking
with
that
water
even the
being
most
its only
devoted
byproduct. Hydrogen can be produced from various sources, stored for long periods, and easily transported. In fact, millions of tons of hydrogen are produced and used safely each year in power plants, electric vehicles, forklifts, ships, and even trains. The Toyota hydrogen combustion engine operates with a fuel cell that converts hydrogen into electricity. Take the Toyota Corolla H2 concept car as an example. It features a 1.6L turbocharged 3-cylinder engine that runs entirely on hydrogen. This is where Toyota's revolution began, signaling a major transformation in the EV industry.
This isn't just any hydrogen engine, it's a complete departure from the all-electric trend that many manufacturers are following.
Reinforced fuel
Toyota has
store
developed
highly
a brand new
flammable
technology,
hydrogen,
one that we've never
inspired
seen
by their FCV, the Mirai. Despite being compact, the Corolla Cross H2 concept car can hold 5 kilograms of hydrogen, allowing for a driving range of around 300 miles. As for its byproduct, it produces just 50 L of water, which, unlike carbon dioxide, is not harmful to the environment. To further advance this concept, Toyota has teamed up with Yamaha Motor to develop a V8 engine powered entirely by hydrogen. This collaboration is pushing the boundaries of what's possible in the automotive world, making it clear that the future of EVs may look very different thanks to Toyota's groundbreaking innovation. This engine is remarkably powerful,
only water from its exhaust, making it a revolutionary step in reducing the global carbon footprint. So how does this engine work?
To give it a unique edge,
instead of following
Toyota
the
added
electric vehicle trend,
one top-mounted exhaust manifold, creating a distinct high-frequency sound. When comparing Toyota's hydrogen combustion engine to other electric vehicles, it has several key advantages. One of the main benefits is its longer range and incredibly fast refueling, almost like a drag race. This also reduces reliance on materials like lithium and nickel, which are crucial for manufacturing EV batteries but are in limited supply. Although the car uses a battery to store some power, it is significantly smaller than those in traditional EVs. As of the last quarter of 2023, the Toyota Corolla Cross H2 concept car was undergoing real-world testing in northern Japan.
When used as fuel, hydrogen is exhaust-free and non-toxic, with water being its only byproduct. Hydrogen can be produced from various sources, stored for long periods.
Toyota's new hydrogen combustion engine stands out as a true game-changer in the automotive industry, one of the most environmentally friendly engines producing only water as a byproduct. It also boasts a longer range, faster refueling times, and reduces the need for scarce materials. We are still waiting on the final results from the real-world tests, but it won't be long before these cars hit the roads. If this hydrogen-powered engine is successful, the Japanese government plans to have around 200,000 fuel cell-powered vehicles on the road by 2025, with a goal of increasing that number to 800,000 by 2030. To support this, they'll need to build more hydrogen refueling stations across the country.
The Toyota hydrogen combustion engine operates with a fuel cell that converts hydrogen into electricity. Take the Toyota Corolla Cross H2 concept car as an example.
The most obvious advantage is its eco-friendly nature. Since it uses hydrogen as fuel, it doesn't produce harmful byproducts, just water. Hydrogen itself is a much cleaner fuel compared to traditional gasoline. Another benefit is the engine's highly effective cooling system. The water cooling feature tackles one of the biggest challenges engines face, overheating. This system could significantly improve the engine's performance and longevity, making overheating issues rare for drivers, which is a huge plus. Additionally, the technology behind this engine is quite familiar. It operates similarly to traditional engines, making it easier to integrate into existing automotive designs and manufacturing processes. For Toyota, this means they can adapt their other vehicles to incorporate this engine.
But how does Toyota make this hydrogen technology work?
However,
their vehicles use reinforced fuel tanks to store highly flammable hydrogen,
the first
a design
is the
inspired
production
by
and
the
infrastructure for hydrogen. While the engine is eco-friendly, its sustainability depends heavily on how the hydrogen itself is produced. Currently, hydrogen production, though widespread, isn't always sustainable. If these cars are to be mass-produced, automakers will need to address this issue. Moreover, the infrastructure for hydrogen fueling is still lacking. Since hydrogen-powered cars are not yet common, there are far fewer hydrogen fueling stations compared to gasoline or electric charging stations.
And as for its byproduct,
this
it
presents a
produces
major
just
hurdle
50
in the
liters of
widespread
water,
adoption
which,
of hydrogen
unlike carbon
vehicles.
dioxide, is not
One of
harmful
the key
to the
challenges
environment.
with hydrogen
To further
combustion
advance
engines is their complexity and cost. While these engines share a similar architecture with conventional engines, they incorporate a dual water injection system. This, combined with a need for precise ECU control, makes the system more complex. Increased complexity naturally drives up manufacturing costs, and owners may also face higher maintenance expenses since the parts are less common. Even if Toyota were to achieve large-scale production, they would still need to address market readiness. As of now, the production-ready version of the engine is still under development and testing. Even when
by
it's ready,
2030.
it will take
To
time
support
before
this,
the vehicle
they'll need to
becomes
build more
commercially
hydrogen
available.
refueling stations across the
Toyota's
country.
development of the
While the
hydrogen
combustion engine has
reflects
already
its
shown it's
commitment to
unlike any
exploring
other.
multiple sustainable transportation solutions. Alongside their electric and hybrid engines, this new technology showcases Toyota's interest in diversifying its eco-friendly vehicle options. While the hydrogen engine promises to shake up the EV industry, how does it differ from traditional internal combustion engines? One of Toyota's standout achievements in this field is the 1.6L 3-cylinder turbo engine, which powers the Corolla Cross hydrogen prototype. This engine perfectly balances traditional design
Hydrogen
with
itself
innovative
is a much
technology,
cleaner
marking a
fuel compared to
significant
traditional
departure from
gasoline.
conventional internal
Another benefit
combustion
is the
engines.
engine's highly effective cooling system.
The 1.6L
The
engine,
water cooling
based on
feature
the platform of the high-performance GR Yaris, has undergone significant modifications to support hydrogen as a fuel source. This led many to wonder, how did Toyota manage to maintain the engine's performance while switching to an entirely different fuel? The answer lies in the hydrogen combustion process. Hydrogen requires different handling and combustion techniques compared to gasoline, and Toyota has equipped the engine with a high-pressure hydrogen direct injection system. This allows precise control of hydrogen delivery into the combustion chamber, optimizing both performance and efficiency. Despite these differences, the engine's overall performance is impressive. The 1.6L engine generates enough
the
power and
technology
torque to
behind this
compete with
engine is
gasoline
quite familiar.
engines, thanks
It
in large
operates
part
similarly
to
to
the
traditional
turbocharger, which
engines,
ensures the
making it
engine
easier
delivers
to
the
integrate
necessary
into
boost for
existing automotive
high-performance driving. However, concerns have been raised about whether turbocharging is the best approach for handling hydrogen's unique properties. Hydrogen has a lower density than gasoline, meaning the engine requires a larger volume of hydrogen to produce the same energy output. Toyota's engineers have faced this challenge head-on, optimizing the turbocharger and other engine components to handle hydrogen's distinct characteristics effectively. One of the standout features of this engine is its remarkable efficiency. In fact, hydrogen combustion engines are significantly more efficient than traditional engines, particularly during high-load situations. This increased efficiency not only improves fuel economy but also
the first
has a
challenge
positive
is the production
environmental
and
impact.
infrastructure for hydrogen.
With better fuel
While the
economy,
engine is
the engine
eco-friendly,
requires
its
less fuel,
sustainability
and
depends
most
heavily on
importantly,
how the hydrogen
emissions are drastically reduced. The only byproduct of the combustion process is water vapor, meaning these engines produce near-zero emissions. Achieving near-zero emissions is crucial for Toyota, as it aligns with their carbon neutrality campaign. Toyota is taking a multidimensional approach to carbon neutrality, integrating both hydrogen and electric technologies into their strategy. While they could have opted for a singular focus on one technology, they chose a diversified path to better meet global needs. But why focus on hydrogen? Hydrogen's potential as a clean energy source is compelling. Whether used in fuel cells or internal combustion engines,
moreover,
hydrogen only
the infrastructure for hydrogen fueling is still lacking. Since hydrogen-powered cars are not yet common, there are far fewer hydrogen fueling stations compared to gasoline.
They've incorporated hydrogen technology into commercial vehicles and public transportation systems. Yet hydrogen alone isn't enough to achieve full carbon neutrality, and Toyota acknowledges this. They have also embraced electric vehicle, EV, technology. Unlike other automakers who focus solely on EVs, Toyota recognizes the challenges facing the widespread adoption of electric vehicles, such as limited driving range, long charging times, and the environmental impact of battery production and disposal. To address these issues, Toyota offers a variety of powertrain options, including hydrogen fuel cell vehicles, plug-in hybrid electric vehicles, and battery electric vehicles.
How does it differ from traditional internal combustion engines? One of Toyota's standout achievements in this field is the 1.6-liter, 3-cylinder turbo engine.
Toward their goal of carbon neutrality. Toyota's approach also takes into account the varying energy sources, infrastructure, and environmental policies in different regions. For example, in areas that rely heavily on renewable energy, BEVs may be the best option. In regions where hydrogen production is powered by renewable sources, hydrogen fuel cell electric vehicles, FCEVs, and hydrogen internal combustion engines, HYCEs, could be more suitable. Toyota's commitment to carbon neutrality goes beyond vehicle emissions. The company is actively involved in reducing the carbon footprint of its manufacturing processes by promoting recycling, resource efficiency, and
not only improves fuel economy but also has a positive environmental impact.
There is still much work to be done
to reach their ambitious goal of full carbon neutrality. The engine requires less fuel, and most importantly,
to fully grasp the impact of Toyota's strategy, it's crucial to take a step back and see the bigger picture. Achieving a carbon-neutral society requires significant changes not only in vehicle technology but also in how energy is produced. Toyota's multi-technology approach, combined with its broader sustainability initiatives, reflects a comprehensive effort to tackle these challenges head-on. Beyond working towards carbon neutrality, Toyota's strategy offers environmental benefits that may be more significant than expected. As the automotive industry transitions to sustainable energy, Toyota's hydrogen-powered internal combustion engines present a compelling option. But how do these hydrogen-friendly
options
compare
available?
to hybrid electric
Achieving
vehicles,
near-zero
HEVs,
emissions is crucial for Toyota as it aligns with their carbon neutrality campaign. Toyota is taking a multidimensional approach to carbon
impact, particularly the emissions profile. Traditional gasoline engines emit substantial amounts of carbon dioxide, CO2, a major contributor to global warming.